Essentials. This is a tutorial on how to guide folks on their cloud native journey using CNCF graduated projects. The first video was on containerizing applications. So we created a Golang application. We also downloaded Docker. With Docker, when Docker build, we were able to create a container image of our Golang application. We ran that container image and we tested it. And our second video was container registries. So we needed a place to host our container registry. And we used Harbor, which is a CNCF graduated project. We installed Harbor. We also installed Docker Compose, since that installation of Harbor uses Docker Compose. So we installed Harbor. We also installed Docker Compose. And we also did some configurations with Harbor as well. For the URL for Harbor, and also since we also use Harbor only with HTTP, so we did configuration for Harbor for that, and also for Docker. By default, Docker requires a secure registry, so if you're going to use a registry that's insecure, you also have to do some configurations for Docker. In our third video, we went over Kubernetes and container orchestration. So we installed several prerequisites for Kubernetes, including a container runtime. For that installation, we use Containerd, which is a CNCF graduated project, which was donated by Docker. And also under the hood of Docker, Containerd is also used. So we installed Containerd and other prereqs as well for Kubernetes. Then we installed Kubernetes, and we went over some basic Kubernetes resources. For this step here, we're going to go over Helm and install Helm. Helm is a Kubernetes package manager, and it is a CNCF graduated project. And Helm helps you install applications and also manage your applications as well. In Helm, we do that with what's called Helm charts. Helm charts is a packaging format. For this step here, we're going to install Helm. So let's install Helm. Let's get the archive for Helm. So Helm charts are also stored in repositories. So we typically call those charts Helm charts and call those repositories Helm repositories. We typically use Helm charts because an application could have multiple containers running as well. There's multiple requirements for a complete application to be installed. So let's say you have a front end or a web server with an application. You also have a back end, might have some caches as well. So a Helm chart is used to deploy something a little bit more complex. So with Helm is installed, we'll go to Helm version -rs client just to test it out. And we see we have Helm 3.13.1. So we're going to use Helm to install our next step, which is metrics. So first off, this next few sections will go over observability. There's three pillars of observability: metrics, traces, and logs. Some people are adding a fourth one, events. So for this step here, we are going to use Prometheus, and Prometheus is a CNCF graduated project. Prometheus stores and collects metrics as time series data. So we are going to install Prometheus using Helm. We're going to use the kube-prometheus-stack, which is a community-maintained Helm chart that will include everything we need for Helm. So include the Prometheus operator, Prometheus with Prometheus rules, AlertManager, the node exporter. Will also include the adapter for Kubernetes metrics APIs, kubestate metrics to get metrics from Kubernetes, and it will also install Grafana so we can visualize our metrics with dashboards. So Helm is installed. We will first add the Helm repo for Prometheus community. So we're going to do Helm repo add Prometheus-community, and we're going to point it where that Helm repo is at, which is prometheus-community.github.io/helmcharts. So the Prometheus community has been added to our repositories. Typically, whenever you add a Helm repo, you always do a Helm repo update. So we were able to grab the latest from those chart repositories. Next, we will use the Helm install command to install the kube-prometheus-stack. But we're going to set some options with that installation. So we're going to do Helm install. We're going to give it the name kube-prometheus-stack. We're going to use the Helm Prometheus-community repository And the chart will be the kube-prometheus-stack. We're going to set some options. So we have some things that are accessible from outside the cluster. By default, some of these services are cluster IP type of services, which means that it is only accessible from within the cluster. So we're going to set the Alert Manager service to node ports so we can see or access the Alert Manager, also with the Prometheus operator, also with the Prometheus service and Grafana as well. We're also going to create this kube-prometheus stack within the kube-prometheus-stack namespace. And we're going to also say create namespace. If you don't have this option, it will require that namespace to be created already. A few more overrides as well. We're going to do the namespace override, of course. We're also going to do more namespace overrides for Grafana and kube state metrics as well. So let's click this to install the kube-prometheus stack. All right, so as this is installing, next few steps, we're going to check to make sure our Prometheus is installed correctly. So this will take a few minutes here. All right, Prometheus is installed. The kube-prometheus stack has been installed. So let's check the namespace and let's check the pods in that namespace with kubectl namespace. This could also be -n. Kube-prometheus stack get pods, and we're going to filter out just for the labels. Release equals kube-prometheus stack. All right, they're up and running. If you're going to do the same, if you do kubectl get pods -n kube-prometheus stack without the filter for the labels, we have several more as well. In this case, we also have the Grafana pod that's running and Alert Manager pod that's running as well. So let's take a look at the services that expose several applications. With kube control get services -n kube-prometheus-stack -separated. So now we have several services. If you notice, there's several type of services: cluster IP and node ports. Cluster IP are only available from within the cluster. Node ports are available outside the cluster. So we're going to use several of these services to access Prometheus and Grafana as well. So we're going to access Prometheus. We're going to go to our node's IP on port 30090 with this link here. If you click too fast, you may not get Prometheus running, but since we went over some topics, Prometheus was ready. So next, Prometheus uses a language called Prometheus Querying Language, or PromQL, to query metrics. So we'll just do a simple PromQL from here. What this is, it shows the total amount of CPU time spent over the last 5 minutes. But it's been less than 5 minutes since we've actually have Prometheus running. Next, we will access Grafana as well. So let's click on the link to Grafana. This will require a login. So we're going to use the default login. I'm going to go to here. It's admin and prom operator. And Grafana is a way to visualize your metrics. So we will go to dashboards. There's several dashboards already built in. So let's go to Kubernetes. Let's take a look at the kubelet dashboard here. So we have one kubelet running since this is just a single node cluster. We could see we have 17 pods running, 30 containers, because of course you could have multiple containers within a pod as well. And that's your high-level overview of how to install Prometheus, which is a CNCF graduated project. Also on how to run a simple PromQL query and how we could visualize our metrics through Grafana.